Assalamualaikum and very good afternoon. So we continue for the next parameter in the chemical parameter is the alkalinity. So alkalinity is defined as the quantity of the ions in the water that will react to the neutralized hydrogen ions. So alkalinity is thus they measure the ability of the water to neutralize acid. Okay. Common ion that you know can be counter to the hydrogen ion is the hydroxyl ion OH. Okay, this is the common and that you know. OH. Okay, instead of the OH, we also have the carbonate ions and bicarbonate ions, CO2, 3 and CO3, HCO3 minus 1. Okay, the three of these ions can be increase the pH because they will be react to the hydrogen to make sure the water is not too acidic. Okay, they can neutralize if the this ion highest, the mole of this ion highest than H plus, so the water can become more basic. Okay, more basic base. Okay, so this is the basic formula, this equation that you can know how you can measure for the alkalinity in the mole per liter or milligram liter as the calcium carbonate. Okay, so if the mole HCO plus 2 carbon dioxide plus OH minus H because the hydrogen ion can be make the water more acidic. Okay, so we need counter, so this ion will be counter to the hydrogen ion in the unit milligram per liter. So this is the formula. Okay, similar, this ion will be counter with the hydrogen ion. Okay, so plus minus. So here have the 2 in the mole, but for the in the milligram no 2 no 2 here. Okay, so alkalinity is measured to determine the ability of the stream to resist change of the pH. Okay, I can result from the dissolution. Okay, this is the natural phenomenon. So how the environment can produce increase the alkalinity or counter with the hydrogen ion in the water by dissolution of the calcium carbonate in the limestone network. This is the natural phenomenon. So the value between 2 to 200 ppm. So ppm the or additional is the milligram per liter. So 1 ppm equal 1 milligram per liter. Okay, if the level of the alkalinity less than 10 ppm indicate the poor buffer stream. So that means if they less than 10, so they quite difficult to counter with the hydrogen ion in water. So they can make the water is more acidic. Okay, that's why the common value is the 20 to 200. So make sure the pH of the water may be between 6 to 7 or 6 to 5 to 7 to 9. So the between this range to make sure the water in the good condition. In the last quantity, okay, alkalinity impair the bitter taste. So the alkalinity, if the pH are more than 10 11, so the taste of the water more bitter. So reaction then occur. Instead of that, alkalinity, if you in the alkalinity water, when they react to the other ion, the precipitation reaction will be occur. So precipitation will be resulted of the salt. So the salt have the solid the result of the salt or solid in the water. So certain pipe, so if the alkalinity in the pipe is the highest, so the others ion in the water will be react to the alkalinity and then resulted in the salt or solid. So solid will be block of the pipe and then they accumulate in the pipe and then they block the flow of the water, and then also for the other system appetances. So they will disturb the water system punya appetances. Okay, this is the example how you can calculate for the alkalinity. Okay, for the last video we already to know how we compute for total hydrogen carbonate total hardness carbonate hardness and non-carbonate hardness. So the alkalinity for this topic. So and this question asks to compute here. This already know. So how to compute the alkalinity and construct the bar chart. Okay. Similar compute for the hardness. So concentration of the X divided by X multiply 50 mg calcium carbonate. Okay, this one we need multiply 50 because we need the answer in the term of the calcium carbonate. So similar as the hardness. Okay, you get the answer. So ini dah settle. Similar for the hardness. So just for the alkalinity. So alkalinity in this question just given for the bicarbonate ion. So carbonate ni tak ada, so they just given here. So the answer is the 90.1 mg per liter. If the given the carbonate, hydroxide and hydrogen in the water, the concentration, so you need to plus and minus. Okay, if no, you just take here. Okay, ni I thought TH jika TH less than alkalinity ni less than alkalinity, then CH equal the alkalinity and non-carbonate is the equation. If the larger, you need similar lah, total hardness minus carbonate hardness, and then you can get the answer. Okay, this is the bar chart, just create. Okay, this is the axis as the milligram per calcium carbonate. Okay, so now we proceed for the oxygen demand. So the oxygen demand we can measure based on the mechanism. Okay, based on their mechanism, either the oxygen demand due to the biochemical, okay, chemical and nitrogenous, due to biochemical, chemical and nitrogenous. So before we proceed for this measurement, so we need to know what is the theoretical oxygen demand. Okay, the theoretical oxygen demand define that the substance required of the O2 and produce carbon dioxide and hydrogen. So that means the formula, the reaction substance plus O2 and produce carbon dioxide plus H and water lah, can produce the water. Okay, calculate the stoichiometry. Calculate by stoichiometry if the chemical composition of the substance is known. So chemical composition ni apa? Because if we know what is the substance, so we can compute using this reaction. Okay. After that, to compute the TOD, amount of X is the substance lah. X is the substance and molecular weight of the oxygen. Substance, what is the molecule amount or concentration of the substance? This one molecular weight of the substance here X X here, and substance X here. Okay. X. This one amount, this one molecular weight. Oxygen here, how many oxygen required. Okay, and then you can know what is the theoretical oxygen demand in milligram per liter as in the unit milligram per liter. So this is example. Compute theoretical oxygen demand. So the given 908.7. So this one amount. Okay, glucose. So this one adalah, what is it? This is a substance. Okay, substance. First, balance reaction gram. This one you can find in the periodical table and determine theoretical oxygen demand. So this is the basic yang saya kata tadi. So here is the substance, oxygen required, produce carbon dioxide and hydrogen. Okay, so let's say the question given the glucose is a C6H12O6 plus, okay, plus O2 and produce carbon dioxide plus water, H2O. Okay, H here 2, H here 12. So must be multiplied with the 6 to get the 12. Okay, you need to balance. Okay, and then C1 is C6, so you tak here 6. Okay, so the total oxygen here is the 6, 12. So 18 oxygen. Okay, oxygen here is 1, 2, this one 6, 8. So they remain 10, more 10 6, So 6, 18, 6, so 12 12 divided by 2, so you get the 6. So you dah already balance the equation. After you balance equation, and then you find the molecular weight of the glucose, and then oxygen required. Okay, oxygen required here is the 6. So oxygen is the 16. Oxygen is the 16. 16 you multiply with 2, multiply with 6, you get then 192. So here you substitute 109 based on the question given, the amount of the substance, and this one you find from the periodic table, and then complete for your theoretical oxygen. This is the way how you can find the theoretical oxygen demand. Okay, this if the 10 mg, so you can try 10 mg and you check get the answer or not. Okay, 10.7 mg per liter of the oxygen demand. Okay, okay, previously theoretical, and then we proceed to the measurement of the oxygen, dissolved oxygen. One of the method measurement is the find the biochemical oxygen demand. So before that, we need to know what is the biochemical oxygen demand, BOD. Okay, in the abbreviation we use the BOD. Okay, so here mention that the microorganism using the oxygen to oxidation of the organic matter. So here they have the three component. So the first microorganism that use the oxygen to oxidize the organic matters. Okay, in other words, we already measure the chain of the DO, dissolved oxygen in the water concentration, cause the microorganism that they degrade the organic matter. Okay, so let's see so saya explain. So ini dalam air, in the water. Okay, so they have the organic, okay, organic matters. Saya buat apa kotak-kotak ni so this one organic matters. So they have the microorganism. Okay, microorganism yang dot. Okay, so to live in the microorganism, to live in the water, so they need to use the organic here to degrade this organic here. So to degrade the organic here, so they required O2. So O2 is one O2 in the water. So they use this O2 to degrade that organic matter in the water. So they use sampailah the organic matter in the water is the less or become to the 0. Okay, so they use the O2. So when the highest organic matters, okay, highest organic matters, OM, higher organic matter, that mean microorganism will be work more, okay, to degrade organic matter here. So when the microorganism work more, so they required O2 more. Okay, dissolve oxygen DO, dissolve oxygen more. When they use the DO, high DO, so that means the DO in the water will be decrease. Okay, so that represent the highest of the BOD. Okay, that represent the value of the concentration of the BOD is the high. When the BOD concentration is high, so that categorize, that indicate that the water is the water quality of the quality of the water is the poor. Okay, boleh faham understand So organism, if the organic matter higher in the water, so microorganism will be extra work. So when they do extra work to compress, to degrade the organic matter, so they require more oxygen, dissolve oxygen in the water. So they will reduce the amount of DO in the water to degrade the organic matters. Okay, so this is the standard oxidation. Okay, 5 days. Okay, in standard method dalam standard method examination of the water, you can find this standard in the Google ke, you find this one, but they have the a lot of the standard. Okay, a lot of the standard based on the parameter, how to measure the BOD this way, how to measure COD, ammonia, and so on. All the parameters, they have the standard that you need to follow to conduct the experiment to determine the concentration of that parameters. Okay, for COD, BOD usually they use 5 day, BOD5, BOD5. So BOD5 represent for BOD in the 5 day, after 5 day. Okay, after incubated for 5 days. Sometimes they have the BOD7, BOD3. Okay, but in the standard method, they measure for the BOD5. Okay, this is the apparatus that you need to conduct for the BOD experimenter. So take the sample water, dilute with the oxygen saturated water. Okay, add nutrient and mechanism. So this one for the seeded BOD. The seeded BOD, when your DO, okay, when your DO in the water is that's maybe DOU less than 5, so you need to do for the seeded BOD. If your DO in the water between 6 point something to the 7, so you can directly without the seeded. Okay, to measure the DO level for over 5 days. Okay, temperature 20. Okay, must be in the dark. You incubate in the dark condition. Okay, to prevent algae from the growth. If you have the sunlight, so photosynthesis process will be occur. So when if you give the sunlight after the 5 days ke 3 days ke, so slime will be appear on your bottle. That's why you need to the dark bottle or incubate in the dark bottle. Okay, so in the standard, this one in the standard method, you can find the standard method. The state that the 2 mg change in the 5 day. Maximum allowable DO depression over the test bed must is the 5 mg per liter. Okay. Okay, this is the formula that you can use to measure for the BOD. So you first DOD initial, DOD final, and proportional volume of sample use divide by total volume. Okay, total volume ni represent for the total volume of the bottle. Okay, sample volume depend on the volume you fill up in the bottle. Okay, kena clear. So DO in the blank should be not deplete more 0.2. DO sample should not less than 2 mg. Okay, final DO sample should not less than 1 mg. So you need to comply with this requirement. So to make sure your experiment will be accepted. Okay, accepted. Okay, if your DO for the blank less than 0.2, so that means your experimented invalid not valid. So you need to do you need redo again for the experimenter. Jadi example how you can measure for the BOD. Okay, so the given sample 19, bottle 300. Okay, 300. So you kena understand here P, here's sample volume divide by total volume bottle, total volume for this bottle 300. Sometimes question given like this. Okay, we conduct the experimental, they fill up with the 10 mg sample and 290 milliliter of dilution water. If the question given in this term, that means the sample volume is the 10. Okay, total volume is here. Total volume plus dia ni dilution water plus dengan sample water, so you get 3. So you need divide by 300, not to divide by 290. Okay, the formula is the total volume, not total dilution water. Okay, so you need to question and read the question properly. Okay, so the question given day 175, day 5 is the 15, so the difference is the 2.5. Okay, 2.5 acceptable because there must be more than 2.0. Okay, so divide, you can get the BOD is the 7.75 milligram per liter. Okay, so unit make sure this one must be milligram per liter, and volume must be in the milliliter. This one unit not this one, because the ratio, so the already cancel off the unit here. Ratio, no unit. Make sure sample volume and total volume have the same unit, because the ratio, so no unit. It's 1 milligram per liter, so the answer in the milligram per liter. Okay, this is the model BOD as the first orderation. Okay, first orderation. So here is the organic matters oxide, how many. So makin hari, day by day, the organic oxide will be increase lah, and organic remaining in the water will be degrade, because the organic was degrade by microorganism. Okay, mula highest, they degrade day by day, they will be. This is the first order reaction. Okay, so first order reaction in the mathematics, you know, okay, dy dx equal negative kt. This is the first order reaction in the BOD. So L we represent for the amount of oxygen, T time, okay, T amount of the oxygen. So this one you can be integrate, okay, integrate using the separable method. So dLT LT equal negative k dt. So this one akan dapat ln LT ln LT, so present T negative k kt, okay, plus C nanti, plus C. So this one you simplify, and then finally you can dapat here LT equal L0 exponent T. So this one exponent lah, ln LT exponent negative kt, okay, C. So center plus, and finalize, you can get for the LT equal L0 exponent negative T. So what is the LT, what is the L0? Okay, so L here, L0 tolak LT, so you can dapat here. So this one the L total volume, so here is the ultimate, so the BOD exerted, so this one nilai T yang remaining. So for the 5 day here lah, 5 day you can dapat here, this is the value of the BOD 5. Okay, so to compute for the ultimate biochemical oxygen demand L0, okay, so at any time ultimate oxygen demand L0 equal BODT plus LT. So assuming that the deoxidation in the first order, so you can get rearrange the equation, this one. Okay, so you tahu tadi LT sama dengan L0 exponent KT. LT equal L0 exponent negative KT. So you tahu L0 sama dengan BODT plus LT. So LT sama dengan BODT, LT BODT. So LT equal L0 BODT. So you substitute L0 BODT in this one, so you akan dapat L0 BODT equal L0 exponent negative T. So this one simplify, and then you can get BODT L0 L0 simplify lah. So that's why jadi 1 here. Simplify, and then you get BODT equal L0 1 minus exponent negative T. So to find the BODT at any time, so you can use this formula, BOD5 ke, BOD6 ke, BOD7 ke, so you can use this BOD formula. Okay, so the equation example if the BOD 5 of the waste is the 102 milligram per liter and BOD 20 is the 158 milligram per liter, what is the K? Okay, K tu you can back the basic. So you tahu BOD T equal L0 1 minus negative KT. So the question need to ask what is the value of the K. Okay, using this formula you will arrange and then substitute with the value. So BOD T, this one BOD T BOD 5 lah, and 20, and because the set BOD 20 ni represent for the ultimate BOD, so L0 is the ultimate BOD. Okay, ni ultimate BOD, ni BOD anytime. So you just substitute the value and then find the K. Okay, so the K is the 0.21 per day. Okay, this is the temperature dependent of the BOD rate reaction. So how you can change the K depend on the temperature. Okay, the rate will be based on temperature. So theta here 1.13, so you substitute here. Okay, so temperature kat berapa? Temperature watt, temperature unit. Okay, so let's say temperature 24. Okay, so K untuk 24, K20, theta 24 minus 20. Okay, so K20 commonly can be in your question. Okay, the example, what is the K? Temperature 25 and 10. So the question asks for this one, determine for the K. Okay, K25. So the given K20 20 day. Okay, you masukkan lah. So here depend on the previous lah, ni theta ni. Okay, and 20 theta. Okay, so this is the answer. Just apply the formula. Okay, so we proceed for the BOD rate reaction. Okay, BOD rate reaction. Okay, graphical definition of the BOD rate reaction. So the kinetic, the basic kinetic is the BOD T L0 ultimate 1 minus negative KT. Okay, negative KT. So this one represent for the kinetic. Okay, kinetic reaction. Okay, kinetic reaction. Okay, time, so DO. Okay, this one kinetic reaction. Decrease and negative. So based on the graphical method by Thomas, okay, they want this curve, okay, change to the linear line, and then you can determine the L0 and K. Okay, how you can determine the ultimate BOD and K based on this graphical method by Thomas graphical method. So the way from this curve they conduct, okay, they do experiment to develop the linear line, okay, based on the first order kinetic. So they found that 180 KT equal KT1 plus KT6 negative 3. Okay, so this is the formula for the linear, okay, for the linear. So how you can do, if you have the data, you need to plot y axis sama dengan T divide by BOD 1/3, and y axis is the T. Okay, you plot here and then you can get straight line. Okay, you can get straight line. Okay, so based on here you get intercept. Okay, intercept value you can get the, okay, this is the linear equation. Okay, so slope here you get the value slope, and then you can get the intercept value. Okay, when you determine the intercept and the slope value, so automatically you can find the K and L0. Okay, so K and L naught. Okay, you can K and L naught. Okay, let's say we do some example. So you have this data, okay, 2, 4, 6 and 10 days for the BOD. So compute for the T over BOD, because you want to plot the linear line, straight line, T BOD T power of 3 divided by T. So you need to plot this one, and then you can get here. Okay, so you get the intercept and do the plot, you then get intercept here, 0.22, and slope here A over B lah, A over B. You akan dapat slope. What is the value of slope? 0.125. You get the slope here. Okay, A over B over A here divided by B here. Okay, what is the A and B here? Okay, don't confuse here. Don't confuse 10. Dia depend lah. Dia tak kisah. This one dia ambil daripada 10. Dia ambil slope here. Dia ambil slope here from here. This one 10 minus 0 and 3.8 sini. Okay, 2.2 here. You also can slope here. Boleh juga you using this one slope. No problem. Either one. Let's say you know what is the height of the A. The important thing, you know what is the height of the A. Okay, to measure the slope, tak kisahlah you want to take any slope. So let's say you must be know what the height of the A and what the length of the B. So M equal A divided by B. So you get this and this value. Okay. So after you get the A and B value, and then you substitute here. Okay, A and B that you already know, B and A you already know, so just multiply and then you can get K and L naught, A and B, so you can get L naught. This is the way how you can find the K and L naught. L naught is the ultimate ultimate BOD ultimate by using graphical method. Okay. Oxygen demand, okay, is using the chemical oxygen demand. Okay, so the base of the fact, all organic compound with a few exceptions can be oxidized by action of the strong oxidizing agents under acid condition. Okay. Okay, this is the typical lah, or the by term 2.25 BOD. Okay, but this one just approximate or estimation, not the correct. It's not the correct way to determine COD by multiply with 1.25. No, this is just for the indicator. Okay, just indicator. Okay, when you get the value BOD, okay, you can estimate the COD by multiply with the BOD. But this way you cannot use for the analysis data. Okay, so what is the COD? So COD is the measure similar. Okay, but this one the oxidize using the strong chemical oxidant. Okay, if the BOD using the microorganism, theoretical substance that oxidized by oxygen. Okay, required oxygen to oxidize. Okay, for the COD, oxidation by strong chemical oxidant. Okay, they're using the potassium dichromat. Okay, organic matter in the sample could be determined by oxidation with dichromat. So dichromat, the strong chemical will be used to degrade the organic matters. Okay, this one the method, this one different with the BOD, because the COD you're using the strong chemical oxidant. So the amount of the oxygen that the chemical equivalent to dichromat consume is defined as the COD of the sample. Okay, during the oxidation, sample is the heat with the excess of dichromat. So yang dichromat, what is the amount dichromat not used to degrade of the oxygen, and organic matters is the convert to the carbon dioxide, water sama CO2 and the water, CO2 plus H2O. Okay, while dichromat reduced become the chromium. Okay, chromium ion, chromium ion. The excess dichromat is determined by means of the oxidation reduction titration, and then lastly you need to titrate with the ferrous ammonia sulfate. Okay, that is the COD. So for the nitrogen oxygen demand, as you know, BOD of the vessel composed of the two components. Satu carbonized. Okay, so BOD, total BOD and you compute to BOD5 only depend on the microorganism. Okay, microorganism degrade the organic matters. For the total BOD, TBOD, okay, composite of two, one bicarbonate and the second is the nitrogenous. Okay, traditionally become of the slow rate of this organism, nitrosomonas and nitrobacter. This one adalah organism. Okay, organism for the nitrogenous. Okay, that exert the nitrogenous demand. It has to be assumed that the non-nitrogenous demand is exerting during 5-day BOD test. Dia ada tapi dia terlampau slow. Okay, during the 0 to 5 day, okay, this organism, nitrogenous organism is not active. Okay, not active. Dia ada but slow within 0 to 5 day. Okay, after that barulah dia start to degrade the organic matters. Okay, so here nitrogenous, carbonized, and the total you need to plus 2 and then you get the total BOD. Okay, total BOD yang you measure is the BOD5, BOD saja, only BOD. This one only the BOD. Okay, only BOD. After certain time, so the BOD, the organic will be degrade by carbonized and also by nitrogenous. Okay, nitrogenous comprising of the two organism as I mentioned earlier. Okay, so this is the two-step process. Okay, they're using the nitrosomonas and nitrobacter. Okay, this is the overall reaction. So ammonia required oxygen, okay, to degrade the organic. So theoretical nitrogenous BOD, so the equation is the how many gram oxygen used, how many gram of the oxygen, nitrogen oxide. Okay, nitrogen oxide here, oxygen used here. Okay, so the answer, this is the answer to determine for the nitrogen BOD in O2 per nitrogen. Okay, this is the typical value untreated domestic wastewater. So ultimate carbonous BOD between 215 to 315. Ultimate nitrogenous BOD 70 to from 70 to 230 mg. So ultimate MBOD, okay, this is some indicator. So you can sometimes you can compute the MD nitrogenous BOD by 4.57 multiply total digital nitrogen. Total digital nitrogen is the sum of the ammonia nitrogen, okay, plus organic nitrogen. Okay, total digital nitrogen. So the total digital nitrogen between 15 to 50 milligram liter as nitrogen. Okay, so next for the chemical parameter is the nitrogen. So what is the nitrogen? Okay, nitrogen is often the limiting nutrient in the ocean water and some stream. So they commonly found in the ocean and sometimes in the stream, in water bodies. Okay, nitrogen can exist in the numerous form, but the commonly in the our stream, the main parameter of the nitrogen is the nitrate, nitrite, nitrate and ammonia. Nitrite, nitrate and ammonia. This is the common that used to measure the nitrogen in the water. Okay, source of the nitrogen commonly from the fertilizer and the acid deposition. Fertilizer for the plantation. Human integration in nitrogen cycle. Okay, additional of the nitrate oxide, nitrate oxide as atmosphere from the burning fossil also causes the acid rain. Okay, and to atmosphere from the bacteria acting on the fertilizer, destruction of the forest, grassland and wetland. So no more trees to absorb of this nitrogen's gas and the excess nitrate to the bodies of the water. Okay, excess nitrate ni maybe from the plantation or household and so on and remove nitrogen from the topsoil. Okay, so previously, okay, sometimes this is our profile land. So in the topsoil ni almost have the accumulation of the nitrogen and will be absorbed on the and will always absorb in the topsoil. That's why for the agriculture, for the good land, they have the high amount of the nitrogen in the soil. Okay, so when you remove the soil, so the end will be passing or will be break and then contribute or releasing to the our stream. Okay, that is the source. Okay, this is the figure show the nitrogen cycle in the terrestrial ecosystem with major harmful human impact. What the human activity that contribute to the increasing the amount of the nitrogen in our environment. Okay, so for the humans, commonly these factories, okay, industrial, burning fuel, organic, so nitrogen oxide, okay, they will be released to our emitted to our atmosphere and then go down back to the earth. Okay, plantation, this from the human activities. Okay, so uptake by plant. If you remove the plant, so the nitrogen cannot take by plant. So for the naturally, volcano also contribute. Okay, composition in the soil. Okay, sediment. Okay, so the red line is the effect by human, and the blue is by naturally lah. Okay, fertilizer. This one from the fertilizer go to soil and also go to water bodies. Okay, you can read. So this one naturally by denitrification, nitrification. Okay, by plant. Okay, decomposition by animal. Okay, so this blue all of the natural path. The red is the by human activities. Okay, cycle to water, the occurs and living organism, limited factor for the plant growth. So the impact of the human activities. All the figure, this is the summary from the figure. What is the sources of the nitrogen from our environment? Okay, how about the phosphorus? Okay, so phosphorus, the red line is the by human activities. Okay, from the sewerage treatment plant. Okay, if they not treated well, okay, so they will be discharged to the water. Fertilizer, okay, mining. Okay, this is the part of the activities that contribute of the phosphorus to the our environment. And the blue line is the naturally. Okay, no problem. Naturally, okay, the natural contribute to the our environment. But for the human activity, usually will be increased or add up. Okay, add up the amount of the phosphate in our water bodies. Okay, and then water bodies to our environment, and then eventually it will be polluted our environment, water, land and so on. Okay, one of the effect of the nitrogen phosphorus is the eutrophication. Okay, eutrophication is mean the algal bloom. The algal bloom when the highest, okay, excessive amount of the nitrogen and phosphorus in our water bodies, so they will accelerate the algae grow, and then the will go, and then and green here is all the alga, because excessive amount of the nitrogen and phosphorus doing day by day, and finally when the algae will be die, will be deposit into the bed of the water day by day, year by year. Finally the lake or the water body can be dead, okay, by the end. So no more water in the lake, no more water in the stream due to eutrophication effect. So eutrophication ni they have the level lah, the level the categorize is it the eutrophic and so on lah. So, you can check in the Google Scholar and so on, find the journal what is the categories of the eutrophication. Okay, so now we proceed for the water quality, the third one. First, physical, chemical and biological parameter. So biological parameter, we proceed for the microbial indicator or microinterpreter indicator. So we have the two indicator can show that the quality of the water is the good or not. Okay, microorganism can be used as indicator of the presence of the pathogen or infectious agent that cause illness to aquatic or the terrestrial ecosystem health. Bacteria counting is a simple method to examine the microbial status of the sample. Okay, the most used to determine for the water quality is to find the total coliform. Pernah dengar tak total coliform ni? Fecal coliform E. coli. E. coli, I thought all of you familiar with this microorganism E. coli. Okay, so total coliform, the origin from soil and fecal, from the fecal lah, our biological needs from our fecals. So fecal of human and warm blood animal will be present of the E. coli. So this one is the indicator. So when you measure this microorganism present in the water, so you know, oh, this water will be polluted by something, fecal ke, soil or plant, they come from the soil or plant. Okay, so total coliform usually for the drinking water. So if in the pipeline, and then this is the pipeline, okay, pipeline. So at a certain point, when you measure at this point, you measure for the total coliform, and then you found maybe they have the present of the total coliform. So you know that's the pipe will be maybe burst, okay, maybe burst or leaking. Okay, so the soil will be entering to the pipe, so the water will be polluted by soil or plant. Okay, so you can measure to determine the total coliform. Okay, for the fecal coliform, usually for the recreational water, lake and so on, you can measure for the fecal coliform. This is the class 1 for the primary contact recreational, 200 colonies, okay, fecal colonies in 100 milliliter sample. For the secondary contact recreational, the class 1 must be less than 2000 colony fecal in 100 milliliter. Okay, so E. coli sama juga, in the numbers they have their own standard whether the water using for the agriculture ke, for human activity and so on Okay, pathogen organism that cause human or animal disease colonize that external tract but can live for the period of the time outside the body. So pathogen ni from the human or animal okay, carries may or may not exhibit disease symptom. As this external tract organism is very large number. When the water contaminated by excreta, the organism can be transmitted to the who contact the water. Okay, ni waterborne. Okay, pathogen organism waterborne. They can transmit human to human from the water as their media. Okay, this is the typical pathogen existed in the human feces. Okay, so you can read good and name, okay, associated disease and so on lah. Okay, this is the temperature measure, waterborne ke, ni water, so the media is the water wash, water base, water relate. So this is the description example lah, cholera, typhoid, okay, bacillary, malaria, water relate, malaria, dengue lah. So water relate, that means have the water compounding and so on lah, that allow the mosquito to breathe, okay. So water base, schistosomiasis, okay, guinea worm, okay, host transmission to human, water contact. Okay, for the biochemical invertebrate indicator, so microinvertebrate are useful and convenient indicator of the ecological health of the water body or river. They are almost always present and are easy to simply identify. Okay, bacteria refer the bottom of the waterway. Example, bacteria microinvertebrata include the insect in their larva or nymph, crayfish and clam, snail and worm. All these microinvertebrata will be show that the water quality is in the good condition or not. If the presence of this microinvertebrata in the water, so you know, oh, this water is very have the good quality, because this microinvertebrata is the sensitive insect, okay, sensitive organism, okay, so they only can live in the good water quality, okay. Okay, this example, Philemon, Nindite, okay, Terite, so siput ke, ada this insect lah. So if you found this insect ataupun udang kecil ni in the water, so you know lah that the water have the good quality. If this Philemonite ni not present in the water, so maybe the water is not good. Usually this insect or this micro bio you can find in the waterfall at the upstream punya area. In the downstream I sure lah you can find this microbiota in the downstream punya river, okay. Kalau you nak find this microbiota, you can find in the upstream river, okay, in the upstream, because the upstream the condition of the water usually have the good condition, okay. The example, okay, so okay, we close with the topic water sampling. So why we need to sampling the water, okay, why we need to sampling the water. Sometimes we sampling the water is a guideline ataupun requirement from the authorities body. Okay, sometimes we sampling the water to know the type, the quality of the water on that area. So this is sampling must be depend on the condition, okay, condition of or depend on the surrounding environment of that area, okay. So to verify this sampling, to in other words, this sampling is to verify that the comply with standard, okay, and then we can know the water will be included in this type. What is the purpose, what is the suitable for that water quality, okay. So before you go to the sampling preparation, documentation, okay, collection, preservation, technique and so on, the first step, okay, the first step in the water sampling, you should know what type of the water that you want to collect, okay, what that you want to measure, okay, what the type of the water, either the water you want to sampling for the surface water, you sampling for the lake water, okay, lake water for the river and so on lah. So the first step you need to know, okay, to know what type of your condition of the water sampling, okay. Let's say if you want to measure for the river, okay, for the river, so that's okay, you directly can refer to the National Water Quality Standard, okay. If you want to more river, you want sampling for the river water, so you directly can refer to the National Water Quality Standard. So National Water Quality Standard already mentioned what is the parameter that you need to measure. So the previous day we just discussed about that. So the parameter that you need, pH, DO, okay, ammonia, COD, BOD, okay, suspended solid, okay. This is the parameter that you need to measure if your water sampling is the river. So let's say you have the task and you need to sampling for the industrial, okay, for the industrial effluent, okay, industrial effluent. So what is the parameter that you need to measure for that effluent? Can you follow this parameter? Only follow this parameter? That is the question. Okay, for the river, that's okay, you follow the National Water Quality Standard because they already have the standard for the river. But let's say you have the task for the industrial effluent, so the important thing for the industrial effluent, you need to know what the type of the industrial you want to measure, what the type. So let's say for the textile, okay, textile ke, or palm oil, okay, machinery ke, and etc lah. So you need to identify what industrial that you want to, what the industrial effluent that you want to measure. Let's say for the palm oil, so you should know what is the parameter, main parameter that present in the palm oil effluent, okay, palm effluent. So for the last class we already discuss about the main parameter for the palm oil. Okay, let's say okay, for the palm oil, mana dia? Okay, this is palm oil, palm oil meal, palm oil meal effluent. Okay, here is the palm oil effluent. So from that you know, so you need to study first. So what is the standard parameter that you require to measure for that certain industrial activities. So let's say for the palm oil meal effluent, so this is the standard common parameter that you need to measure. So let's say pH, COD, BOD, all increase, ammonia. So they have the certain heavy metal here, magnesium, calcium, zinc, iron. So that's why you need to know. The first thing for the water sampling, you need to know what is a parameter that you need to measure. Okay, so for the river, it's okay, you can directly measure using the standard. If the palm oil effluent have the standard, have their own standard, so you need to follow that standard. On that standard, what is the parameter that you need to measure it? Okay, this is the first thing, must be know the type of the water sampling. Okay, so after that you need to prepare the bottle, okay, storage, filter, sampling, rubber bottle and so on lah. And documentation, pen, sampling, film, notebook, okay, for on-site test, okay, analysis to be performed on the site. So all this one for the collection, precision of the sample, you can refer for the standard method ni yang saya kata standard method tadi, and BOD tadi for the BOD, how they measure BOD using the standard method. So in this standard method have the way or standard that you need to follow for the collection and preservation of the water sample. Okay, this is screen collect list most contaminated sampling location. This one for river, this one for river, this one for river. This is example for the river. sampling for the sediment water being collect water first. Okay, for shallow stream, start downstream, work upstream to minimize sediment effect due to sampling disturbance. If the sampling different depth, collect surface sample first and then proceed the deeper. Okay, always collect volatile organic compound first. Okay, followed by as suspended volatile compound, then total metal dissolve. Okay, this is the sequence sequence how you can collect the sample based on the standard method. Okay, amount minimum sample required depend on question of the analysis present. Okay, 100 milligram and 100, how many amount, 100 milliliter, okay, 10 milliliter, 1 liter. So you want to test duplicate, okay, 2 times, triplicate. Okay, so you need to know how many volume that you require to test for the sample. Okay, so kalau you ambil lebih, too much, so akan problem pada storage and transportation. So transport, all this related about the cost. Okay, so the example for total volatile hydrocarbon 5 ml, metal 100 ml. Okay, trace organic pesticide they using the 1 liter. Okay, as general rule of minimum volume collected should be 3 or 4 times the amount required for analysis. If the analysis require 10 milliliter, so you multiply lah untuk save, because you want to do to duplicate and triplicate. Okay, maybe you can take 100 milliliter and so on. This is the way how you can decide for the volume of the sample. Okay, and then after you know the volume and then the transportation and so on, so the next step is the preservation and storage. Okay, so the purpose, minimize physical, chemical, biological chain. We want to make sure the physical, chemical, biology of the water still remain same as in the site. Okay, three approach can you be used: refrigeration, proper sample container, education of the freezer chemical. Okay, this one untuk refrigeration. So 2 and 3 degrees Celsius in the dark. Okay, so boleh chemical addition. Okay, proper container, either using glass ke plastic. Okay, the cap. Okay. So the method process, can you use microdegradation, chemical reaction, okay, absorption, diffusion and photoreaction. Okay, sample preservation and storage. Refrigeration is usually okay, method to slow down the loss of the process. So they want to avoid any changes of the physical, biological and chemical of the waters. Container choice, okay, the type and headspace to reduce volatiles, okay, absorption, diffusion and photoreaction. All this process we need to avoiding, okay, avoiding doing your sampling. Okay, addition of critical to the loss to chemical reaction and bacteria degradation. Okay, this is the sample preserve and the storage. So let's say you in the foam tadi yang kita ada, we look at the foam chemical characteristic of the foam, they have the metal, is it the metal so the container, okay, that you using is the plastic bottle. Okay, chain doing the storage, preserve, okay, glass wall, absorption to the glass wall, and so the metal will be absorbed to the glass wall and precipitation. So untuk preservation you must be using the plastic bottle and add the nitric acid to make sure the pH less than 2. Okay, untuk make sure the metal not be absorbed or precipitation during your storage. Okay, so let's say you have the organic. So organic usually we want to measure for BOD, okay, COD and so on lah. So organic, so the organic will be react with chlorine. So you add this nitrate sulfate oxide ni to remove free chlorine. Okay, so make sure your container not have any chlorine. Okay, and so on lah. Dia ada macam-macam sini. So depend on the type analysis, type of the parameter that you want to analyze. Okay, maximum holding time is the length of the time a sample can be stored after collection and prior to analysis. So before your analysis, how many long you can keep the sampling. Okay, for the pH, temperature, salinity, DO, immediately. So usually we can measure in situ in situ measurement. Okay, so for the within 1 2 day, so you must be plan well your doing your sampling. So make sure you look for the day, Friday, Saturday and holiday, so they didn't have the gap time, so you make sure avoid that gap time doing your sampling. Okay, the selection of the sample container, so glass and plastic. Okay, glass may leach boron and silica, metal may stick to the wall. So whether you want to sampling using the container sampling using the glass or plastic, so this one you need to look at the parameter that you want to analyze. Okay, so similar to headspace or no headspace. If the VOC no headspace, so maksudnya the full lah, water is the full. Okay, special container, VOD, DO bottle and VOC. This one untuk experimental. Container ni for experimental. Okay, experimental they have their own container. Okay, this is the collection of sample. Okay, so here alkalinity, acidic, carbon, chloride, for example. So this is the container. Jadi plastik, okay, glass, fiber plastik. So, di sini dia plastik, glass, okay, range width dia ada ni lah, glass. So they have the mention here what you should do. Okay, kalau sulfate ni boleh pakai this one. So here is the volume, is it? Okay, sample sample volume. Okay, so ada lah sini, so you can tengok lah which one depend on the water sampling. Okay, mercury here. Okay, kalau heavy metal commonly kita pakai plastik okay. So we stop here, and for DO set curve I will discuss for the next week class. Okay, thank you.